Friday. We are really coming down the home stretch. I hope you all are kind of excited about that. We have this video, and then next week, and then the last week we'll review, we'll take a test, and then we'll review for the final. So we only have 4 videos left. This is really exciting, and the last, oh wow, really winding down. So this is in Blackboard. We're going to join forces on some property of exponents sections. They're 2 short, pretty easy sections. Just takes a lot of practice. And so what I've done is I've summarized all the rules that are in these 2 sections, some of which we've already done. So just as a review, you'll hear me talk about the base. You'll hear me say the power, which is another name for the exponent. And then some of these rules we've already done. So if you're multiplying like bases, right, we've talked about this, you keep the base and you add the powers. So here, let me give you an example. So x cubed times x squared, you see how the bases are the same? You keep the base and just add the powers. When you're dividing like bases, you keep the base and you subtract the powers. So for example, x to the 5th over x cubed, you keep the base and then you subtract the powers. Numerator minus denominator. All right? If you have a base to a power that's been raised to a power, now look, do you see that the parenthesis is separating those? Parentheses between 2 numbers means multiply, right? If I said 5 times 6x, that means multiply. Same with these guys. So if a parenthesis is separating exponents, I think about multiplying. I make that parenthesis into a multiplication symbol. So you keep the base and you multiply the powers. If you have a product that's being raised to the power, this is the only time you're allowed to distribute that power. If there's a plus or a minus in there, no, don't let anyone trick you. It's only the time you can distribute that power is if everything's either multiplied or divided. If every factor is being multiplied or divided, then you're allowed to raise each of those factors to that power. And then anything to the 0 power is 1. And then this one's a biggie. So you're not allowed to have a negative power or a negative exponent in a problem and have it be considered simplified. All right? So, for example, if I had x to the negative 2, and that was my final answer, my math lab's going to go, well, your answer is correct. It is not written in the simplest form. So you have to imagine that is in the numerator of a fraction, and you're going to bring it down to the denominator and make the power positive. Same as if you have a negative exponent in the denominator. You're going to take that and bring it upstairs, and you're allowed to make the exponent positive. We okay? And the reason being, like, 2 to the negative 2 doesn't make a lot of sense to me, but 1 over 2 squared does. That's 1 over a 4th. So this is a quarter, but it's hard for me to understand that unless I rewrite it with a positive exponent. All right, so all we're going to do is apply these rules over and over and over. It's not too exciting. Look at all this practice. So I'm going to do a couple. You're going to stop the video and do a couple, but that's all we're going to do for this video is just practice. So simplifying expressions involving exponents. First of all, your final answer is not allowed to have a parenthesis in it. All right, no parenthesis. Each variable or constant appears as few times as possible. So, for example, if you have 2 x's, you better only have 1 in your answer. All right? Make sure you evaluate numerical values. So make sure you're like negative 2 times 6, you put negative 12. All right? If you have a fraction, make sure you reduce the fraction. And then make sure each exponent is positive. All right, so I'm going to go through them slow. I'm going to say you guys pause it, you guys couple, turn back on the video. All right, I'm going to do 2 and then you try that one. So if you have like bases and you're multiplying, you keep the base and you add the exponents. The only time you multiply them is if there's a parenthesis separating the exponents. All right? Like here. You see the parentheses are separating the exponents? That's when you multiply. Parenthesis means multiply. All right. So, like I just said, parentheses are separators, mean you're just going to multiply everything. So let's get rid of the parentheses and put a dot in between so I know I'm multiplying. Multiplication is commutative, so if you want, you can flip the x and the 3 so the coefficients are together. You don't have to take that step if you don't want to, but y'all know I'm anal, so I like to do it. So 15, and then when you're multiplying like bases, you keep the base and you add the powers. So try this one. Now pause the video. It kind of models after this. Everything's multiplication, so pause the video, drop your parentheses, and see what you got. All right, let's try it. So negative 2 times x to the 7th times y cubed times 6 times x to the 8th times y to the 4th. Okay, the associative property says we can multiply any two factors first. So I'm going to take care of the negative 2 and the 6, and I'm going to call that negative 12. And then I'm going to dip in, and I'm going to find my x terms. I'm going to multiply these guys next. So I have like bases, and I'm multiplying. I keep the base, and I add the powers, right? And then the next two terms I'm going to dip into, I'm going to dip into those y's. So if I'm multiplying like bases, I keep the base and I add the powers. So look at that. I only have one x, I only have one y term, and I have just one coefficient term. All right, so if everything is being multiplied together, you can raise everything to the power that is outside that set of parentheses. So do you see I dropped the set of parentheses? Now be careful, if there's a constant or a coefficient, the 5 has to go not only to the x and the y, but it also has to go with the 2. And then you need to be able to calculate that out. It says each numerical expression has to be calculated. So if you put 2 to the 5th into your calculator, you'll get 32, x to the 5th, y to the 5th. Now this one is super easy. Anything raised to the 0 power is 1. You don't need to distribute through. Negative 3 to the 0 and x to the 0 is just going to be 1 times 1. Anything to the 0 power is 1. All right. Now when I see these, this is how I think about it. So first I deal with the fraction. So 6 over 3 is, here I'm going to leave a fraction. 6 over 3 would be 2 over 1. And then I have more x's on the top than I do on the bottom. So I know my x term is going to be on the top, and it looks like I have 4 more x terms on the top. So we don't even need the fraction anymore because there's just a 1 in the bottom. Does that make sense? So here, I'm going to make my fraction. 14 over 21. Look, guys, you've got your calculators, and you can use your calculator on everything. So you could just put 14 over 21 in your calculator and hit enter, and that's going to give you the simplest form, right? Remember the ND key? So hit the ND key. We've got 14 on the top, 21 on the bottom. Simplest fraction right there. So 2's on the top, 3's on the bottom. Okay, now where am I going to put my x values? Well, I have x to the 5th on the top, x to the 7th on the bottom. So I know there's more x's on the bottom than on the top. How many more? 2 more. That's the way I think about it. And then so I look at the y's. I have more y's upstairs than downstairs. How many more? 3 more. Y to the 9th, y to the 6th, y to the 3rd stays up there. Hey, isn't that easy? That's not bad, right? Okay. And here is just to get rid of the parentheses. This is the one where, since everything is being divided or multiplied. To get rid of the parentheses, that power, that exponent, will go to each of those factors. Right? Anything to the 0 power is 1. Those are the easiest ones. We love those ones. A base to a power to a power. Do you see these powers are being separated with a parenthesis? Parenthesis means multiply. So that will be a to the 24th. Parenthesis means multiply. So that'll be x to the 54. All right? Okay. So, look at all these problems. Why don't you pause the video and try, I don't know, at least try the first row, okay? There's not a heck of a lot new until we get to some of these negative powers. So just maybe try the first row and then come back and we'll see how you did. All right, so this 2 is going to be an exponent to the 6. And it's going to be an exponent to x third. I had to put parentheses in there so it doesn't look like 32. So 6 to the 2nd power is 36. And then if you separate them with parentheses, you multiply. So it would be x to the 6th power. I'm running out of ink. Okay? So this isn't any harder, it's just more factors. So it would be 2 to the 5th, x to the 7th, or x to the 7th raised to the 5th, and y to the 3rd raised to the 5th. You see how that works? So 2 to the 5th is 32, x to the 7th to the 5th is x to the 35, and then this will be y to the 15. Alright, now this one, there's a 1 understood that's there. So you've got negative 1 to the 4th power, and then times t to the 3rd raised to the 4th power. So negative 1 to the 4th will be 1 times t to the 12th, or you can just write it as t to the 12th. Alright, why don't you try these ones? Pause it. The best way to do these is just to practice, honest to goodness. You just practice, 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 and they'll get really easy, okay? But you got to practice them enough to know where you have some work that you need to work on. So pause the video and do that row, and then come back and join me. All right, so there's a 1 understood there, so it's negative 1 to the 3rd, a to the 2nd to the 3rd. So if you put negative 1 to the 3rd in your calculator, you'll get negative 1. And then again, if the parentheses separate powers, you've got to multiply the powers. So that'll be negative a to the 6th. That's the best way to write that. Not wrong to leave it that way, but this looks better. Alright, so PEMDAS says we've got to deal with these parentheses first. So this will hang out, and then we'll raise 2 to the 3rd power, and then we'll raise the x to the 5th to the 3rd power. So 4 times x squared, 2 to the 3rd is 8, and this will be x to the 15. Alright, so 4 times 8 is 32. And then if we have like bases and we're multiplying, we keep the base and add the exponents. How did you do on that? That one okay? All right. And then, oh, I see a fraction. So I automatically just make my fraction. Okay? Here we go. So let's put in the 15 over 20. So that'll be 3 over 4. Alright, so let's deal with these y's on the top. So that will be y, if you have like bases, you keep the base and you add the powers. Okay, and here's my fraction. So where do I have more y's, upstairs or downstairs? Looks like I have more upstairs, and I have y to the third more. How are you doing? Okay, I'm hoping, like, if we were in class, I'd just have you keep working and then we would regroup. So I'm hoping, like, when I say pause it and try it, you're pausing and you're trying. I would pause these, pause the video and see how you do on those, okay? And then come back and join me. All right, so we're going to raise x to the 8th. That's going to be raised to the 5th, right? Everything gets to be raised to the 5th power. Okay, so parentheses separate, you know, the exponents. You keep the base and you multiply the powers, right? That's the only way you multiply is if parentheses are separating you. Otherwise, you're going to add them. Okay, so that one's done. Wow, lots are going to happen in here. Okay, so everything gets the third power. A to the 6th gets the third power. B gets the third power. 3 gets the third power. And C to the 5th gets raised to the third. All right, so pull out your calculator. 2 times 2 is 4. 4 times 2 is 8. So we'll have 8. I'm going to multiply those. The 18 b cubed all over. Put that into your calculator. That should have given you 27 c to the 15. And there it is. How'd you guys do? So hard for me not to be able to walk around and look, see how you're doing, if there's anything we need to cover more of. All right. Oh, this one should have been like, woohoo, we like these, because anything to the 0 power is 1. Done. All right. All right, I'm going to keep going. So let's see. Everything gets to the 5th power in that numerator. So x cubed gets raised to the 5th. Y to the 7th gets raised to the 5th. And then the y to the 10th just hangs out because it doesn't have, it's only what's in the numerator that gets raised to the 5th power. So this will be x to the 15th, y to the 35th, all over y to the 10th. So where do my y's stay? Do they go upstairs or downstairs? Well, I have more upstairs, right? So this will be x to the 15th. And then how many more do you have upstairs than downstairs? You see you have 35 here, 10 here. So you're going to have 25 more up in that numerator. And the denominator is just 1, so we don't need to worry about it. All right. So this guy, I'm going to bring this guy down here. So we know if we have like bases, we keep the base and we add the exponents. But you can't have a negative exponent. So since this is in the upstairs technically of a fraction, we're going to bring it downstairs and then make the power positive. Now it's simplified. All right. So all parentheses, let's just drop them. And then we're going to make multiplication in between them. Okay? So associative says you can go anywhere you want when you start multiplying all factors. So I'll do the 4 and the 5 first. And b to the negative 9 times b to the 4th is b, you add the powers. Now look, this 20 is perfectly happy where it is. It does not have a negative power. So this guy has a negative exponent. So the 20 stays where it is, and then the b to the 5th comes downstairs. So you bring that, to make that power positive, you bring it down. Since it's in the numerator, you take it down into a denominator, and then you're allowed to make it positive. Okay. Ooh, pause, pause, pause. Take a pause and try those. This is about as hard as they're going to get. You know, that's a lot. You'll have some of these on the test and on the final. But I put some on the wow for you to practice first. All right. We've got negative 4 times b to the negative 1 times c squared times 6 times b to the third times c to the negative 4. All right, let's do the numbers first. Here we go. Let's take care of those. So that's negative 24. All right, let's check out the b's now. We have b to the negative 1 times b to the third. When you're multiplying like bases, you keep the base and you add the powers. Right? Negative 1 plus 3 is 2. And now we've got these c ones, right? So c squared times c to the negative 4th. So you keep the base and you add the powers, right? So that'll be negative 4. All right. You cannot have a negative power. You're allowed to have a negative coefficient, so that negative 24 is perfectly lovely. The b squared is perfectly lovely, so these guys can stay right where they are. It's the c to the 4th that's going to have to come downstairs so we can make it a positive exponent. We good? All right, so everything gets the 5. All right. If parentheses separate the powers, then you multiply them. So this will be 32, b to the 10, c to the 15. All right, very different from this. So we're just going to drop the parentheses and just put a multiplication symbol because parentheses mean multiply. So we've got 3 times 2 is 6. B cubed times b to the 6. You keep the base and add the exponents. All right, so we just took care of those. And then c to the 4th times c to the 6. You keep the base and you add the exponents. That good? All right. Last page. Flip a lip. Here we go. All right. So this one, that negative 2 is not very happy. So first let's take care of the negatives. So if we bring that downstairs, there's the original b squared, and then this one's going to come downstairs and we'll make the power positive. And then if we have like bases, we keep the base and we add the powers. All right, this guy, not happy, right? Because it has a negative power, so we just bring it upstairs. So this will be 5x to the third. All right, you want to take a pause and try these 3. See how you do? Let's see, so you're going to have a fraction. If you put 3 over 12 into your calculator, you'll get 1 over 4. All right, so we have more b's upstairs than downstairs, so that would be b to the 5th, b to the 7th, b squared, you have 5 more upstairs. Then here you have 1 more c upstairs. So you'll have b to the 5th, c over 4. Right? Oy. All right. So what I usually do with these is, first of all, let's just deal with the coefficient. Right? So you can just put 35 over 25 in your calculator and hit enter. And that's going to simplify that fraction for you. Okay? So we're going to have 7/5. Now I'm going to make everybody happy first, and then we'll deal with the exponents. So the only thing that's allowed to stay where it is the c cubed, or the c to the third. So b to the negative 9 is going to come downstairs and become a positive 9. And b to the negative 7 is going to come upstairs and be a positive 7. C to the cubed stays where it is. And then this guy also has to come up because it's unhappy. So to make it happy, to make that power positive, you bring it upstairs. If it's downstairs, you bring it up. If it's upstairs, you bring it down. Hoi. Okay. So here's our fraction. So let's deal with the b's. Where do we have more of them, upstairs or downstairs? Looks like we have more in the denominator, so how many more? 2 more. And then both of the c terms are upstairs now, or factors are upstairs now, so if you're multiplying like bases, you keep the base and you add the powers. Okay? So I like dealing with the negatives first and then move on from there. Okay, but this guy, we have to deal with the exponents first. There's different ones in the numerator and the denominator, so let's take care of each. So we have 3 squared, b to the second, and then c to the 5th to the second. See, everything gets to the second, and then down here, everything is going to get to the 3rd power. So we'll have 2 to the 3rd, b to the negative 2 to the 3rd, and c squared to the 3rd. So it's a lot of steps, but it's not hard steps. So we'll have 9b squared c, I'm going to multiply those exponents to the 10th. All right, we'll multiply those, so that would be 8b to the negative 6 c to the 6th. So let's make that b happy, right? This b is the only thing that's unhappy, so we got to bring it upstairs. So we'll have 9b squared, b to the negative, positive 6 now, whoop, positive 6, c to the 10th. And then downstairs, 8c to the 6th. Right? That's going to be positive. All right, so here we go. Finally, we're going to get this one done. It's a beast. So upstairs, we've got 9. When we have like bases and we're multiplying, we keep the base and we add the powers. All right, 8 is downstairs. And now decide, where are we going to put the c, upstairs or downstairs? Well, where do you have more of them? You have more of them in that numerator. How many more? 4 more. Right? So it's not hard. It's just a lot of steps. You just have to be patient. And don't try to combine more steps. Like, don't try to do more steps in one shot. Try to take it multiple steps, right? Don't try to combine anything too fast. All right, just a couple more to go. This is a short, this will be shorter. All right, so let's distribute. Everything's multiplied in here, so we're okay to distribute that exponent. Right, you're not allowed to distribute if it's a plus or minus, but if it's everything's being multiplied, you're good to go. So we'll have 2 to the negative 4 times b to the negative 4 raised to the negative 4. So we'll deal with that in a second because we're going to have to make that happy. So I know I'm going to need a fraction. So we've got 2 to the negative 4, and then if your exponents are separated with parentheses, you're going to multiply them. Right? Okay, so now we've got to make that 2 happy. So the b to the 16 gets to stay on top. The 2 to the 4th will come down, right? When you bring it downstairs, the power becomes positive. And if you put 2 to the 4th into your calculator, you'll get 16. How you doing? Only a couple more to go. You ready? Okay, so this will be b to the negative 5. Oops, sorry about that. B to the 4th, all raised to the negative 5. And then we'll have c to the negative 7, all raised to the negative 5. All right, so if we multiply, we'll get b to the negative 20, c to the 35, because a negative 7 times negative 5 is a positive. Not so happy, so we're going to bring him downstairs. We're going to make a fraction and bring him downstairs. Okay? All right, now I understand. I get it. You could just do that on your calculator, but we're just going to do it without. So when we have like bases and we're multiplying, we keep the base and we add the exponents. Or anything to the 0 power is 1. Let's check it. You ready? Just for kicks. So 13 raised to the 500 times 13 raised to the negative 500. Whoa, overflow. Wow, okay. So we can't do this on our calculator. Well, that's cool. So we really do need to learn these rules. I didn't realize our calculator wasn't going to like that. Oh, that's so cool. Huh, okay, I'm so happy. So it's a good thing we know these rules, right? What it means by overflow 13 to the 500, it's just too big. The calculator can't calculate it. It's too many digits for it to think about as far as being programmed. So, yay. All right, I'm going to put my calculator away. All right, for this guy, you keep the base and you add the powers. It's not happy, so we're going to have to bring it downstairs into the denominator of a fraction, and that'll give us 1 over 49. All right, and then this is about as hard as they get. So I gave you a hint. Simplify what's inside the fraction first and then distribute through the negative 4, because there's a lot going on in here. We can make this look a lot cleaner if we clean this up first. So let's go ahead and make everything happy. Well, it's 18 over 6 is just 3, okay? So we'll have 3. And then the b to the negative 3 will come upstairs and be b cubed. B to the negative 4 will go downstairs and be b to the 4th. And then we have, well, we can deal with this. So where do I have more c's, upstairs or downstairs? More upstairs. How many more? 5 more. All right, so let's keep going. So now let's deal with the b's. So where do I have more b's? Looks like I'm going to need that fraction for sure, because it looks like I have more b's downstairs, and I have 1 of them downstairs. All right, so now it's not so bad. Now everything's going to get a negative 4 power, right? So we'll have 3 to the negative 4, c to the 5th to the negative 4, and b to the 1st to the negative 4. All right, let's make everything happy. Well, first let's multiply through. So we got 3 to the negative 4, c to the negative 20, all over b to the negative 4. So you see you have to flip-flop everything to make these powers positive. So my final answer, here I'll do it in pink. You ready? We're going to have b to the 4th upstairs, 3 to the 4th downstairs, and c to the 20th downstairs. And then 3 to the 4th is 81. So we'll have b to the 4th all over 81, c to the 20th. Whew, that is a long, hard problem. No lie. No lie. That's a tough one. All right, let me just give you a warning, because this is what I find people make mistakes with. You ready? People will look at this, and they'll look at this, and they'll forget. If everything is multiplication or division, you go for it. You can take that 2 and raise every factor to the 2nd power. If it's not multiplication or divisions, dude, you can't do that. You've got to remember your rules for multiplying polynomials. You know I like my box method. If you want to FOIL it, go for it. But you can't just raise everything to the 2nd power, or you'll drop your middle term. So you've got x squared, xy, xy, and then y squared. Do you see what I mean? So it's x squared plus 2 of these xy's plus y squared. So do you see you can't just distribute, that's a 2 right there, you can't just distribute that power. If if everything is not multiplication. So if you got addition or subtraction, you've got to think about it as the product of, in this case, two binomials and do your box method. Only if it's multiplication and division are you allowed to distribute that exponent. All right? All right? This is awesome. So guys, we only have 3 videos left. Next week, that's it. 3 videos, one oh wow. We're really coming down the home stretch. The last week of school, we will review Monday, take a test Wednesday, and review for the final on Friday. So we are coming down. I'm proud of you guys for sticking with this. This is awesome. So have a good weekend. Feel free to Zoom me if you have any questions this weekend. And I hope you, before you Zoom me, you have to send me a remind on the phone, or otherwise I won't know to open up a Zoom room. Okay, anyway, have a great one, guys. I look forward to seeing you soon.